For 60 years, humanity has aimed massive antennas at the stars, listening for a simple radio transmission to confirm we aren't alone. And for 60 years, we've heard absolutely nothing. We funded enormous projects, dedicating supercomputers and thousands of researcher hours to sweeping the cosmic dial. Based on that total silence, the logical conclusion seemed clear. The Milky Way is either completely empty, or advanced civilizations simply do not exist. But a June 2026 study from the SETI Institute points to a different answer. The messages might already be here, hidden right inside our own data. According to the study, the signals are arriving. We just don't recognize them because they are being actively scrambled and warped long before they reach our telescopes. Our standard search tools were tuned to a version of physics that simply doesn't survive the trip from a distant star to Earth. This graph illustrates exactly what scientists have been searching for: a perfectly sharp, ultra-narrow spike in radio frequencies cutting through natural static. The reasoning is straightforward. Natural cosmic processes produce messy, randomized waves. A pristine, concentrated peak must be the product of manufactured technology. That assumption makes perfect sense in a vacuum, but it completely ignores the violent physical realities of the environment surrounding the alien transmitter. Before a clean radio broadcast can cross interstellar space, it has to physically punch through the chaotic, churning outer atmosphere of its own sun. Imagine an advanced civilization successfully beaming a highly concentrated message out into the dark. Almost immediately, that signal hits a wall of turbulent energy. The space surrounding a star is filled with fluctuating plasma density and explosive stellar storms, known as coronal mass ejections. These extreme forces act on the radio wave, physically bending and warping its structure. This animation shows the effect in action. The star's plasma wind catches that sharp white peak and scatters its energy outward, flattening it into a much wider, fainter green smear. That flattened, smeared version is what eventually crosses the galaxy and hits our receivers here on Earth. The problem lies entirely in our software. Our detection algorithms are specifically coded to flag sharp spikes, so they completely filter out these wider, degraded signals. The alien star effectively cloaks its own planet's broadcasts. Real extraterrestrial messages slip entirely beneath our detection thresholds, perfectly disguised as natural cosmic background noise. The evidence proving this interstellar scattering effect didn't even require a deep space telescope. The data was already sitting right here in our own solar system. Researchers looked at historical radio transmissions sent by human space probes operating near our sun. By analyzing these signals, they could measure exactly how local turbulent plasma affects narrow radio bursts. They took those local measurements and scaled them up, building a mathematical framework that predicts how the same physical processes would warp signals leaving other star systems. By decoding our own local space weather, scientists mapped the mechanics of signal scrambling across the entire Milky Way. When they applied that math to the wider galaxy, the results highlighted an enormous problem. The equations pointed directly to M-dwarf stars. Because M-dwarfs are highly active and produce intense stellar storms, they are exceptionally good at breaking apart and hiding narrow radio transmissions. This map highlights exactly why that matters. M-dwarf systems account for roughly 75% of all the stars in our galaxy. Because the vast majority of stars actively destroy the exact type of signal we are hunting, SETI programs are now redesigning their entire approach to target wider, messier signatures. The universe is a loud, chaotic environment that actively reshapes communication. We are finally learning to look past the hunt for a perfect whisper and start analyzing the noise.